Welcome to Deep Research TV, where we dive deep into the most mind-bending and awe-inspiring mysteries of the universe. Picture this: a region in space so dense, so powerful, that nothing, not even light, can escape its grip. It devours everything that gets too close, stretching objects into infinite spaghetti and crushing them into nothingness. Black holes, the ultimate predators of the cosmos. They're often called the most terrifying things in the universe, and for good reason. They challenge our understanding of reality, bend the laws of physics to their breaking point, and lurk invisibly across the galaxy, waiting to consume. But are they really as monstrous as they seem? Or are they also keys to unlocking the deepest secrets of existence? Today, we're re-exploring the science of black holes, from their formation to their terrifying effects and the latest discoveries that have finally let us see them. First, what exactly is a black hole? It's not a hole in the traditional sense, no tunnel or portal. A black hole is an extreme concentration of mass packed into an incredibly small volume, creating gravity so intense that space-time itself curves inward catastrophically. The boundary around it is called the event horizon, the point of no return. Anything crossing it is lost forever to the outside universe. Inside lies the singularity, a point of infinite density where our laws of physics completely break down. The idea traces back to Albert Einstein's general theory of relativity in 1915. Just a year later, physicist Schwarzschild solved Einstein's equations for a spherical mass and found a solution implying these objects, but Einstein himself doubted they could exist in reality. It wasn't until the 1960s, with work by scientists like John Wheeler, who coined the term black hole, that they became accepted theoretically. How do black holes form? Most come from the deaths of massive stars at least 20 times the sun's mass. When such a star exhausts its nuclear fuel, its core collapses under gravity. In a fraction of a second, it implodes, rebounding in a supernova explosion that blasts outer layers into space. If the remaining core is massive enough, about 3 solar masses or more, gravity wins completely, collapsing it into a black hole. We've observed indirect evidence in binary systems where a star orbits an invisible companion that rips material away, forming a glowing accretion disk that heats to millions of degrees and emits X-rays. There are different types. Stellar mass. Black holes range from a few to about 100 solar masses. Then there are supermassive black holes, millions to billions of times the sun's mass, sitting at the centers of most galaxies, including our Milky Way's Sagittarius A*, about 4 million solar masses. How these giants form is still debated, perhaps from mergers of smaller black holes or direct collapse of massive gas clouds in the early universe. What makes black holes truly terrifying? Let's talk about falling in. As you approach the event horizon, tidal forces, gravity stretch become extreme. For a supermassive black hole, you might cross the horizon without immediate notice. But for a stellar mass one, spaghettification hits hard. Gravity pulls stronger on your feet than your head, stretching you vertically and compressing horizontally into a thin stream of matter. Time also dilates dramatically from your perspective. You fall quickly, but to outside observers, you appear frozen at the horizon, redshifted into invisibility as light struggles to escape. Inside, we can't know directly because no information escapes, but theory says you'd hit the singularity in finite time, where density and curvature become infinite, ending in total annihilation. Black holes also warp space-time around them, creating gravitational lenses that bend light from background stars, producing eerie rings or multiple images. Yet black holes aren't completely black. In 1974, Stephen Hawking revolutionized our view with Hawking radiation. Quantum effects near the event horizon create particle-antiparticle pairs. One falls in, the other escapes, carrying energy away. Over immense timescales, black holes evaporate small ones, faster than large. A stellar mass black hole would take longer than the universe's age to vanish, but tiny primordial ones could explode dramatically today. This resolves the information paradox debate. Does information swallowed by a black hole disappear, violating quantum rules? Recent ideas suggest it's preserved in subtle radiation patterns or on the horizon itself. Real evidence. Cygnus X1, discovered in the 1970s, was the first strong candidate. Today, LIGO and Virgo detectors have caught dozens of black hole mergers through gravitational waves ripples in spacetime from colliding behemoths. The first detection in 2015 confirmed Einstein perfectly. The breakthrough came in 2019. The Event Horizon Telescope, global network of radio, telescopes imaged the shadow of M87's supermassive black hole, a glowing orange ring around a dark void, 55 million light-years away. In 2022, they captured Sagittarius A*, proving a monster hides in our galactic center. Black holes terrify because they represent the unknown, devouring light, time, and matter. They could end civilizations if one wandered close, though the nearest known is thousands of light-years away. Rogue black holes might drift through space, invisible until they disrupt stars. But they're also creative forces. Mergers seed new stars, and accretion disks power quasars, the brightest objects known. Supermassive black holes regulate galaxy growth by heating gas, preventing overformation of stars. Future missions like the upgraded EHD or space-based gravitational wave detectors like LISA will reveal more intermediate mass black holes, mergers, and perhaps quantum gravity clues near horizons. Black holes embody the universe's duality. Destructive yet essential, terrifying yet beautiful. They remind us how fragile reality is at extremes. What scares you most about black holes? The spaghettification, the singularity, or the idea that information might be lost forever? Share in the comments, like if this blew your mind, and subscribe to Deep Research TV for more cosmic deep dives. Until next time, stay curious about the dark.